Hello everybody, welcome to NEET Physics by Arun video channel. In today's video, we are going to solve a multiple choice question in the chapter Electrostatics from your class 12 syllabus. Okay, that's all. And the question is, a capacitor is charged by a battery. Okay, the battery is removed and another identical uncharged capacitor is connected in parallel. The total electrostatic energy of the resulting system. What will happen to it? It's the question. This question has been asked in the NEET examination in the year 2017. Okay. So, what are the options, sir? Decreases by a factor 2. This is the first option. Number 2, remains the same. Number 3, increases by a factor 2. First one decreases by a factor 2. The other one increases by a factor 2. Increases by a factor 4. So these are all the options. Okay. So charge on first capacitor when it is connected with the battery. Let it be Q. Q is equal to CV. This formula that you know. That means what? V is equal to Q by C. Let it be equation. What is V? Potential of the battery. Rather to say potential of the capacitor. Whatever it may be, Q by C. When the two capacitors are connected, the battery has been removed. Another uncharged capacitor. It means what? Its capacitance is initially 0. Okay. So when the two capacitors are connected, they attain a common potential. That is V common is equal to total charge Q1 plus Q2 divided by total capacitance C1 plus C2. Okay. Now we can substitute the values. For Q1, you can substitute Q because the charge of the first capacitor. For Q2, you substitute 0. Why it is 0, sir? It is an uncharged capacitor. Okay. So this V and this common potential cannot be equal. Okay. So Q1 charge on first capacitor. Q already told you that. Q2 charge on uncharged capacitor 0. Moreover, C1 capacitance of the first capacitor, C2 capacitance of the second capacitor, they are equal to C because it has been given that they are identical capacitors. It means what? Both will have the same capacitance, only C. So V common is equal to Q1 plus Q2 instead of Q1, Q for Q2, 0. Q2 plus 0 divided by C1 plus C2, it is C plus C, 2C. So Q by 2C. You know that Q by C is equal to V. So it means what? V by 2. So the common potential V is V divided by 2 from the equation. Initially the second capacitance has no charge, so there will not be any energy. So all the energy will be of the first capacitor only. So initial energy U1 is equal to half into CV square. Energy of the capacitor half CV square, that you know. Let it be equation 2. Final energy into U2 is equal to half into 2 into 2C because the total capacitor is 2C plus C, 2C divided by V square V by 2 the whole square because V common is equal to V by 2 the whole square. It's equal to what? 1 by 2, 2C, 2C. When the square gets inside, V square divided by 2. Once again, 1 by 2, 1 by 2. 2 is here, 4 is here. So, 1 and 2, 2 etc. So, CV square. What is this half CV square? U1. Already, you have 2 in the denominator. That is equal to U1 by 2. It means what? Final energy U2 is equal to U1 divided by 2. Okay? From equations 2 and 3, you get U2 is equal to U1 by 2. U2 is equal to U1 by 2. It means what? The total energy decreases by a factor 2. So option 1 is the right answer. So here, I have to tell you one thing. Whenever there is a sharing of charges between the capacitors, in this problem, in this question, it is a process that took place. Sharing of charges from one capacitor, charges are transferred, charges are shared into the other capacitor. Whenever there is a sharing of capacitors, the charges among the capacitors, there will always be loss of energy. This is one concept about the capacitors. What is the reason? Why are you telling this, sir? So because in the of the four options, only in the first one, total energy, it has been given that total energy decreases like that. In all the other options, in one option, it is increases by 4. Another one, it increases by 2. Another one, it remains the same. So, as per the concept itself, there will be a decrease of energy only when there is a sharing of charges takes place among the capacitors. If you know this concept, you need not solve this problem. You need not numerically work it out. Even by looking at the four options, you can choose answer one option. Okay? So this is one thing you have to remember. If you remember this concept, you need not work out this problem. You will easily pick the correct option. Okay? Okay. So these are also. So far, we have seen 10 questions put together in round 1 and round 2 in this electrostatics chapter. In the tomorrow's video also, you will see one more question from the electrostatics chapter. Till then, thank you one and all.